Hello, this begins the review of an additional problem from Integrated Math 3, section 8.3.1, where you are given g of x, which is a cubic, and this is again a cubic polynomial, so it's a third degree polynomial, and you're given the graph as well as just the information that it has one real root at x equals negative 2.5. So how could we verify that this was again a real root? Would be to plug this into my equation and verify I get out 0. So is g of negative 2.5 is the same thing as negative 5 halves? Does that really equal 0? If so, then it's a real root. And again, all polynomials, and especially odd degree polynomials, will have at least one real root, one place where they're actually passing through the x-axis. And so we can go ahead and verify that. There was also a graph given to you. I went over that in a previous lesson. And in this lesson, I just wanted to focus on, well, what is the linear factor that it would again be associated with the negative 5 halves? So we could work backwards to figure out that that linear factor would be x plus 5 halves equals 0. And from here, we also would say, well, that looks a little bit funny. I could actually change this so that it actually looks more like what I expect by multiplying both sides by 2. And then I end up with the 2x plus 5 equals 0. And most likely, this will be the linear factor that it's divisible by. Now, of course, you see the 6 here. The leading coefficient is 6, meaning that there's going to be another linear factor that is going to have at least a coefficient of 3, or perhaps this linear factor, I could have multiplied everything through by 6. And again, I can figure out what remains and get it into a more factored form by using an area model. So we are going to use an area model, and because we're going to be dividing it by 2x plus 5, and we're dividing a cubic, that really means that after I divide a third degree polynomial by a first degree polynomial, I'll be left with a quadratic, and all quadratics have 3 terms, like ax squared bx plus c, and that dictates how many columns I have in my area model. Again, here I've got 2 rows because of the fact that there are only 2 terms in the linear factor that I'm dividing by. Now, again, the sum of what's going to sum inside will be the 6x cubed plus 7x squared minus 16x plus 10. And again, we always put the first term, the 6x cubed, inside of the area model. And from there, our whole goal is to figure out the dimensions on the outside of the area model, that when you multiply it by the 2x plus 5, you will get the sum of what's inside to be that original polynomial. So if this side over here is the 2x, and you have an area inside of 6x cubed, this must be the 3x squared that you multiply it by, because again, 3x squared times 2x is going to be 6x cubed. Then multiplying the 3x squared times the dimension of 5, you get a 15x squared. As a reminder, that 15x squared will have to be combined along the diagonal here with another term that will result in just a 7x squared. So that means you've got to subtract 8x from it. And if you subtract 8x, then you've got a negative 8 or negative 4 on the top here, because of the dimension again on the outside was 2. So this should be again a negative 4. And do we need an x? This should be an x squared here. We would need an x, because again, what we really need is that these 2 terms are going to be combined together. So if these 2 terms are combined together, they have to be like terms. And so only like terms have a variable with the same exponent. And so 15x and negative 8x combine to 7x squared. And if you multiply the dimension over here, that's 2x times the negative 4x, that's how you get that negative 8x squared inside there. So now, using a slightly different color, I have to think about what is negative 4x times positive 5, and you get 20x. And this 20x is going to need to combine along the diagonal with another term to actually add to negative 16x. So at first it might think, well, wow, that's going to be a really big number. But maybe we can check our area model here. We've got a negative times a positive, so this really should have been negative. So doing all of these checks will allow you hopefully to catch any mistakes that you might make, and they're pretty obvious because of the fact that you're just figuring out what's the area inside. So do that double check before you then say, oh, okay, well, it's really not that much I've got to add to get to negative 16x. In this case, it's just going to be a positive 4x. And again, if that dimension is a positive 4x and the side is 2x, then I only multiply by plus 2 to get to that 4x. And so now, again, the positive 2 and the positive 5 do multiply to a positive 10. And these two match. And they've got to match. If they don't match, that means that you did your area model or your long division incorrectly. How would I know that? It's because we already took the time earlier to figure out g of negative 5 halves, meaning we plugged in the root, found out it equaled 0. Therefore, these will always match. And if they don't, that might mean you need to go back into your area model, just the way I was, to verify that indeed these two, everything lines up. There's also the possibility that you just try long division. And so I'm going to do the long division. If you'd like to continue to stay tuned, you may. So let's do the same problem long division style. Now we've got to think about how many times does 2x plus 5 go into g of x, and that is 6x cubed plus 7x squared minus 16x plus 10. So how many times does the 2x go into this 6x cubed? That would be, again, 3x squared, and 3x squared times that is 6x cubed. And then times the 5, that would be a positive 15x squared. And then I would subtract these, being careful to subtract 7 minus 15 is a negative 8x squared. Bring down the negative 16x. How many times does 2x go into negative 8x squared? Well, negative 4x times, and negative 4x times 2x is negative 8x squared. Negative 4x times 5 is a negative 20x. And then again, we are going to be subtracting these. So this becomes a negative 8 minus a negative, that's again 0, minus 16, minus a negative 20. Well, that changes into minus 16 plus 20, which is a positive 4x. Bringing down the very last term, plus 10. 2x goes into 4x plus 2 times, and 2 times 2 is the 4x. 2 times 5 is the 10. So again, those two match. So really here, the remainder is 0. And so that again means that your cubic can be factored. And so really the equation y equals 6x cubed plus 7x squared minus 16x plus 10 can be factored to be 2x plus 5 times that resulting quadratic, 3x squared minus 4x plus 2. And how you would find the remaining roots for this would be to use completing the square or quadratic formula if it is not factorable. So again, this here is standard form, and we just moved it into a factored form. And we are now, since we have a quadratic, having the tools that are sufficient to find all of the roots.